at standard function 2, still talking about properties of function, but today we're going to really look at tables. So we're still going to identify the properties of linear functions, but this time we're just going to look at the tables, and again, we're going to look through the slope and the y-intercepts within those tables. So the first question on your notes is, how do I find the slope in a table? So what we're going to do is the verb there is calculate the change of my y values, and we're going to put that over the change of the x values. In math, we usually make a symbol of a triangle for change. So we're going to look for and calculate the y value change over the x value change, and that is going to give us our slope, or as we've discussed before, our rise over the run. So how do you find the y-intercept of a table? Because it's not a graph, it's not an equation, it's an actual table. You're either going to identify because it's given already, or you're going to have to calculate where the value, x value, is 0. And we've had that conversation multiple times, that when we're looking at the y-intercept, x is always 0. So we're going to have to force that x to become 0, that x value to become 0, and that's where we're going to find our y value, which is our y-intercept. So in our first table here, we're going to start with the slope. So as I said before, we're going to calculate the change of the y's. So if I look at the y's, I'm going to notice from 0 to 1 is a change of a positive 1. From 1 to 4 is a change of a positive 3. And from 4 to 7 is also a change of a positive 3. We're going to go over to the x side. Again, I'm looking for how much it changes. So if I start at 0 and it goes up to 3, that is a change of a positive 3. If I'm at 3 and it jumps all the way to 12, that is a change of a positive 9, because 3 plus 9 is 12. If I'm at 12 and I'm going to jump the number line up to 21, you would have to go 9 spaces. So that's positive 12. Now, a couple things I notice. We got two different numbers. So when you go rise over the run, or the change of the y over the change of the x, you have to keep corresponding changes. So 1 corresponds with the change of 3. So the change of 1 in the y corresponds with the change of x of 3. So that would be my rise over my run. Because remember, y's and x are my run numbers. Okay, I can look, and I'll prove it here. 3, they're both 3's and they're both 9's over here. So the corresponding 3 corresponds with 9. And if you think about it, if I have something that is 3/9, well, if I divide the top one by 3, I'm going to get 1. And if I divide the bottom one also by 3, because those are common factors, 9 divided by 3 is also 3. So notice that if you reduce the fraction, you're going to get the same slope. So it doesn't really matter which one. Normally, mathematically, we like to pick the unit rate or the smallest fraction. In this case, it's just the smallest fraction of 1/3. Where's the y-intercept? So as I've said before, it's where x is 0. So right here, this one I can just identify because it is in the table. So this is the point when x is 0, y is 0. So when x is 0, so is y. So that is my y-intercept. And the last step is we're going to make the equation. So we're going to start with, remember, it's y equals mx plus b. So y is our variables. M is my slope, which is 1/3. And then x is a variable. And then b, in this case, is 0. And mathematically, you don't really have to add 0, but I'm going to leave it there just to prove that it does work. One thing that you can always do on these is to check if your math is right, if you have a point on tables. So for example, if I plug in 21 for x, I should get an output of 7, or a y value. So if I take 1/3 of 21 plus 0, well, 1/3 of 21 is like dividing by 3. which is 7. So it does equal 7, which is a good sign, because if I go back over here, when I plug in 21 for x, I should have outputted 7 for y. So I know my equation is right. So honestly, you shouldn't miss any of these if you actually take the time to check them. Next one, again, we're looking for the change of the y, which is your rise, over the change of your x, which is your run. So the change here is from 3 to 4 is just a change of a positive 1. From here to here is 4 up to 7 is a change of 3. And from 3 up to 10 is a change of 3. It looks very familiar. A little bit different numbers, but we're still getting that same change. On the x side, the change between 0 to 3 is a positive 3. The difference between 3 to 12 is a positive 9. And then from 12 up to 21 is you are going to add 9 again. So take one of these. It doesn't matter which one. I'm going to take this first one, and it corresponds, that change corresponds with 3. So 1 over 3. So the change of the y, which is 1, over the change of the x, which is 3. Again, if I would check them since they're exact same before, if I put 3 over 9, we just looked at that before, and it would reduce down to 1/3. Now to find the y-intercept, we're going to look for where x is 0. The good thing about this one, it is actually in the table. X is 0 here. So when x is 0, y is 3. So right there is our y-intercept. Woo, we'll write that again. 0, 3. Got a little crazy on me. Okay. And then last but not least, we put it in our equation form. So y equals your slope back here is 1/3, your variable x, and then if you add 3, because that's your y-intercept, 0, 3. Again, if I plug in a number, it should work. So let's plug in 21 for y. Man, you don't have to pick the bottom one. I just picked it because it's easy to see. So 1/3 of 21. So in other words, 21 divided by 3 is 7. And if I add 3, it equals 10. If I look over here, y is 10. I can guarantee my answer is correct. Again, easy way to check. So change of my y over my change of my x. Let's go through my changes of my y. It's going down 1, so I'm going to use that as a -1. 9 to 8 is down 1. 8 to 7 is down 1. On the x side, 3 to 4 is up, so it's positive. From 4 to 5, you would add 1. And from 5 to 6, you would add 1. So my slope, the y's are changing. They're all the same, so we just say -1. And that corresponds to a positive change of 1. So you can write that as -1 over 1. Or you can simplify it down to -1. We'll do that when we get to the equation. Now, unfortunately, on this one, you can't see the y-intercept, because if you look, we stopped at 3. Now, I'm going to force the table to go back to where x is going to be 0. So if I work backwards, so instead of adding 1, I'm going to subtract 1, I'd get to 2. And that's going to correspond with, if I'm subtracting 1 to go forward, well, then to go backwards here, I'm going to add 1. So 10 plus 1 is 11. So my back point is to 11. Again, I'm going to do that same steps. I'm going to subtract 1, which will give me 1. I'm going to add 1 on the side, would give me 12. If I just look at it, it should be that same pattern. And one more time to get to 0. So I go back, 1 is 0. And I go forward, 1 is 13. So it looks like right here it's 0, 13. So when x is 0, y is 13. Just to check my work, 0, 1, 2, 3, 4, 5 makes total sense. On this side, we're going down by 1. So 13, 12, 11, 10, 9, 8, 7 looks perfect. So equation time, y equals, you can write -1 over 1, or if you want to simplify that, of course, that's just -1, your variable x, And this time my y-intercept when x is 0, y is 13. So it's a positive 13. And the last problem. Whoops. Okay, we're going to go with a change of from 3 to 1. That is a change of -2. So going down, or -2. From 1 down to -1, you're going down 2 or -2. -1 minus 2 is -3, so that is -2. So this is a nice even one. It's going by the same amount each time. On the x side, 1 to 2, we're going to add 1. 2 to 3, we're going to add 1. 3 to 4, we're going to add 1. Got to love it when it's just increasing by 1. So the change of my y over my change of my x, since they're all the same, it doesn't matter which one we look at. So we'll look at this top one, changing by -2, while the x's were changing by 1. The y-intercept, it's not there in the graph, but if we work it backwards, this is pretty simple. Since we're going up by 1, if we go back by 1, I go right to 0, so I don't have to work too hard. And on this side, if I'm going down by 2, to work it backwards, I'm going to add 2. So 3 plus 2 is 5. So my y-intercept is at 0, 5, just to make sure I'm right. I know the pattern is going down 2, and 5 minus 2 is 3. So my y-intercept, I guarantee, is at 0, 5. Write my equation. Y equals, my slope is -2 over 1. I'm just going to put -2 because -2 divided by 1 is -2. X plus, when x is 0, y is 5, and we have our equation. We'll just check this one quick. I'll pick that bottom point. So if I put in 4 in for x, so -2 times 4 plus 5. So -2 times 4 is -8. Add 5, that'd make -3. And if I look closely, the good news is that -3 should be my y value. So I know that is correct. Please continue by practicing finding your slope, y-intercept, and make an equation in the packet on page 21.